Hello friends, welcome to Legend Lens, and today we're going to have a look at something very important about exponential form. I've already made a video about this particular topic. If you haven't watched it, the link is in the description down below. Just check it out and watch before watching this one. This is just an add up to what we've already discussed. Alright, thank you. So now we said that the exponential form is in the form r e exponent I theta. Right, and we're only talking about theta being positive. Now what if theta is negative? What happens? We said r e I theta is actually equal to I cos of theta plus I sine of theta. Now if theta is negative, then we should get negative I theta, which becomes cos of negative theta plus I sine of negative theta. Now we know cos to be an even function, okay, so this is going to turn out to be r cos of theta. Since cos is an even function, the negative sign is not going to play any role. Cos of negative theta is actually the same thing as cos of theta. So, but with sine, we know it to be an odd function. It is an odd function, and so negative is going to play a role. So this becomes negative I sine theta. So RE is when negative I theta becomes cos theta minus I sine theta. So this is basically what I want you to take note of. And another thing is that the exponential form help us to find the logarithm of a complex number. It is only with the exponential function that you can use to find the logarithm of a complex number. This is because it consists of product of these numbers and then an exponent or powers. So now let's see how we find the logarithm of a complex number using the exponential form. Alright, what you should take note of is that when we have log of AB, it is actually the same thing as log A plus log B. Alright, now let's take this complex number which is in the exponential form RE I theta. Now when we find log of both sides, we get this actually natural log of both sides, you get RE I theta. I can simply write this as R multiplying E I theta. Alright, and so this turns out to be natural log of R plus natural log of E I theta. And this comes down here to become in R plus I theta natural log of E. Now we know natural log to be log of E, and then we have this E here, and the log of a number to the same base is equal to 1, and so we have this to be equal to 1. So our equation turns out to be natural log of R plus I theta. So when you have this complex number in the exponential form and you are asked to find the logarithm, you just find the natural log of R, then add it to I theta. So let's take an example and see. So an example we have z to be equal to 6.42 e exponent I 1.57. So now you take natural log of z, which becomes natural log of 6.42 e exponent 1.57, and this turns out to be natural log of 6.42 plus I 1.57. Now final answer becomes 1.8594 plus I 1.57. So this becomes our answer. And again, the result here is also a complex number. So this is something that I thought it would be useful to you, and just something that you need to add to our complex number toolkit. Thank you very much. Subscribe for more such videos. Thank you.